In this first section of our congruent triangle chapter, we're going to talk about congruent figures. We need to define what a regular polygon is for you. A regular polygon basically has all sides equal and all angles equal. So let's go ahead and write that down. All sides are equal. All angles are equal. Okay, and now if we go on to the next thing, we're going to talk about the interior angles of a polygon. That would be the angles inside of a polygon, of any polygon. And there's a relationship here. The sum of all interior angles of a polygon can be found by this formula right here, 180 times n minus 2, and n is the number of sides that the polygon has. Okay, if we want to write, I like to use an S, so the sum of all the angles inside is 180 times n minus 2. So now let's go on to some example problems here. What is the sum of the interior angles of a hexagon? So a hexagon we need to know has 6 sides. And we're trying to find the sum, so that means we're going to plug 6 in for n. So the sum is going to be 180 times, and for n I'm going to put 6, so it's 6 minus 2, which means I really do my 6 minus 2 first, so it's 180. 6 minus 2 is 4, so 180 times 4 is 720 degrees, which would be the answer for all the interior angles of a hexagon. That means the 6 angles inside of a hexagon will add up to 720. Number 2, what is the number of sides in a polygon if its interior angles have a sum of 2520? Now they're giving us the sum and they want to find n the number of sides. So think of putting in 2520 for S. So here's our formula. S equals 180 times n minus 2. And we're going to put 2520 over here for S. So we're going to go 2520 equals 180 times n minus 2. Now we're going to solve this for n. A couple different ways. You could distribute the 180. I am going to choose to divide each side by 180 to get rid of that multiply. So if I divide by 180, okay, 2520 divided by 180 is 14. So I get 14 is equal to, and I have n minus 2 left. I'm going to take it out of parentheses. And then, obviously, to finish solving that, we would add 2 to both sides. So n is equal to 6. Moving on to the next example. What is the measure of one interior angle in a regular pentagon? Now, key thing here is we have a regular pentagon. Remember, regular polygons have all sides and all angles equal. Pentagon, we're dealing with 5 sides here. So we're dealing with a 5-sided figure. And we want to find the measure of 1. So we still use our 180 times n minus 2 because we're going to figure out what all the angles inside the pentagon add up to. So if I put 5 in there, so it's 180 times 5 minus 2, which is 180 times 3, which is 540. And then we're going to always, that's for what all 5 angles add up to, and we're going to divide by how many sides we have, which is 5, because they're all going to be the same, or how many angles we have. So 540 divided by 5 is 108. So one of those angles is 108 degrees. So really what we did is we did 180 times n minus 2, and we divided by n, the number of sides. Okay. The exterior angles, here's the relationship with those. And we're talking about an exterior, when we're talking about exterior angles, let me just draw a pentagon. This would be the exterior angles. If I extend the sides going around in a direction here, okay, we're talking about all of these angles right here. This would be the exterior angles. In every polygon, the exterior angles are 360. It does not matter how many sides it has. So in question number 1, when we ask what's the sum of the exterior angles of an octagon, doesn't matter, it's 360. If it was a pentagon, it would be 360. If it was a hexagon, it would be 360. Any polygon. Now, if we're trying to find the measure of one exterior angle of a regular octagon, regular means they would all be the same. We're basically, again, it's octagon, it's got 8 sides, we're going to take 360, and we're going to divide it by how many sides, because or how many exterior angles there would be, which would be 8, so 360 divided by 8 would be 45. So that means each of the exterior angles would be 45 degrees.